Hello everybody, welcome back. Today we're going to be doing 2.1, the tangent ratio, and we're going to be starting at example 1. Example 1 says determine the tangent ratios for each angle, determine tangent D and tangent of F, right? So tangent of angle D, tangent. So really just want the ratios, okay? So the first thing we need to do is we need to label our triangle. So in the first one, what we're going to do is we're going to be looking for, and I'm just going to steal what the definition of the tangent ratio is. So I'm going to steal the equation there. Okay, make it a little smaller for you. Alright, so the tangent ratio is the length of the opposite side. So now we got a length of the opposite side, right? So if we're looking for, I'm going to change this to tangent F, or tangent D, sorry, we'll do D first. So then we're going to have to label our triangle. So what I've done is we'll grab our triangle out of the textbook, right? So I'll replace the triangle that you're given, and you can label the sides if you want. Okay? So if I'm dealing with triangle or angle D, which you notice I've indicated here, all right? The side opposite that would be 3, and the side adjacent would be 4. So the length of that side, we can replace the length of side opposite with, obviously that would be EF, and the length of the adjacent side, since this here's the adjacent side, that's DE. So we took our definition of our tan ratio, and we've simplified it and added it in. So now what we're going to do is we'll copy that, and we're going to redo that. Tan D is what we're finding. We're not actually trying to find an angle here. We're just learning to do the ratios. So the opposite of angle D is 3, and the opposite of, the adjacent of angle D is obviously 4. So we can leave it like that, or it can be represented as a decimal, 0.75. Oh, sorry, equals 0.75. I would just leave it as a fraction personally, but again, that's up to yourself. And do we do the exact same thing with looking for of F? So then we're going to have to relabel our triangle this time though, however. This triangle here was for D, so we're going to have to relabel our triangle. Okay. We're going to call it F, so I'll grab that diagram as well. Alright. So you'll notice the angle's in a different location because we're referring to angle D here. And this one we're referring to angle F. So you'll notice obviously the adjacent and the opposite sides have switched spots, which obviously makes sense. So in this case, the 4 is in the numerator and the 3 is in the denominator, because this here is actually DE this time, and this one here is EF, right? Because the opposite and the adjacent have switched locations. And you can do that. I like leaving it as a fraction for obvious reasons, because this is one decimal, and obviously the 3 is going to repeat. Hence why I am not a fan of decimals all the time. So we could just leave it. Only the bar above this. Somewhere here. There we go. There it is. Alright. So 1.3 and has a little line above it, indicates that 3 repeats. Okay. So you guys can do the check your understanding question. It's there. You're doing the exact same thing. This really is just an exercise for us to learn to label our triangles, really. So if you're talking about angle Z, 12 is opposite, 6 is adjacent. If you're talking about angle X, 6 is opposite, 12 is adjacent. So essentially that's it. Okay? So let's look at example 2. it says example 2 says using the tan ratio to determine the measure of an angle. So this time we're going to actually calculate the angles using the tan ratio. Okay. So you can steal this again. So in this time, remember, we're looking for the tan of G, and this would be the opposite over the adjacent for short. We don't have to write those out each and every single time. So if we do that, remember that our triangle, we're going to read, there's our original triangle, we're going to label it. So I'm going to get the other triangle that we need to label, and when we label it, it looks like this. Right? Get rid of that old one. Don't mind the HG up here. Just ignore that. So the side opposite of G would be 4, and the side adjacent would be 5. So remember, opposite is the one directly across from it, and the side adjacent is the one attached. Okay? So in this case, the opposite side is 4, and the adjacent side is 5. So before we just show the ratio. In this exercise, we're actually going to calculate that angle. So this is where we do the inverse on our calculator. And I'll do it again with you just to make sure you have an understanding of that. So this time we take the inverse, so it's second function, tan, and then we're going to put in the 4/5 or decimal 8. It doesn't make a difference. And you get 38.659 the dot to dot. Okay, so let's plug that in. So to represent that, we show that angle G is equal to inverse tan of 4/5. Alright? And do that on a calculator like we did before, and I know it's showing on the screen. And we get 38. Oh, sorry. Take that with me. 38.659.80825. Okay? And it says the nearest tenth of a degree, so that means the 5 is going to round the 6 up to a decimal 7. So we get 5 rounds the 6 up to a 7. And then don't forget our degree sign. So it's 38.7 degrees. Okay? 38.7. And you do the same thing for J. Alright? So that was for the first one here. And if I would get that, I'll get that diagram for the next one. Text, just so you can see it. There it is. Don't mind the top right corner. So again, you do the same thing, but you'll notice that the opposite and the adjacent have changed locations because we're talking about angle J now. So 5 is opposite now adjacent. So it's basically just the reciprocal, right? So I'm going to do this for a second. So we'll look for angle J this time. So something you can put J or just angle J. It doesn't make a difference. Usually you'll just see it as a solid J like that. Okay. And remember, the opposite is now 5, the adjacent is 4, so it's essentially reciprocal because we're looking for the other angle, right? Let's do this again, just to help us. So angle J is equal to, remember, it's the inverse of 5/5, 5/4. Right, and you're going to calculate that on your calculator. So you should get your calculator at this point. Right, and I'm going to do that now. Inverse tan of 5/4 or 1.25, and that gives you 51.340, 19175, and so on. And we're going to round that. So angle J is equal to 51, and then the 4 rounds that leaves a 3 and a 3. We get 51.3. All right, and that's it for that example. So in number 1, we just found the ratio. It was literally just an exercise to determine each side. In this exercise, what we're doing is actually finding the angle, not just what the ratio is, but the angle pertaining to that. And there's a few for you to try here and check your understanding. Instead of trying to rush another example, and that's it for this video. In the next video, we'll finish up example 3 and example 4 of the booklet. Okay. Thanks for watching, and I hope this has helped with learning some of these new ideas around trigonometry and primary trigonometric ratios. So, thanks again, and we'll talk again soon.